The last thing that we need to talk about in this chapter is the value of the discriminant. Now, the discriminant is the part of the quadratic formula that we find underneath the square root, and that tells us a lot about what the equation is going to do. Remember, the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac, and then all of that is going to be divided by 2a. So this part here, the b squared minus 4ac, that's what we call the discriminant. And the value of the discriminant will help us determine two things. It'll tell us how many solutions or zeros the equation is going to have, and it will also tell us what kind. We can either have real number solutions, or remember what we saw the other day is that we can also have imaginary solutions. Now, the value of the discriminant, if we tie all of this back to be a square root, because that's where that b squared minus 4ac comes from, it makes it much easier, I think, to remember. So if we want to figure this out, all we have to do is take our values of a, b, and c and plug them into just that b squared minus 4ac part. If the value that I get is greater than 0, well, numbers greater than 0 would mean, oops, that's a highlighter. Numbers greater than 0 would mean that they are positive. If my value of b squared minus, if it's positive, then what that means is that I'm going to have two real solutions. You will get numbers that do not contain any i's. And we've kind of talked about this before. If I get two solutions that are both real numbers, that means that what I'm coming up with is two solutions, and those solutions represent the zeros or the two locations where the parabola is going to cross the x-axis. Okay? If the value of the discriminant is equal to 0, then that means that we just get one real solution. And I'll show you a case of how that would happen. But what would happen if I just have one is that means that the only point that touches the x-axis is the vertex itself. And so it just kind of skims off and bounces off of the x-axis right there. And so that's why we only get one real solution. The last option is if we get two imaginary solutions. That's going to happen if the value of b squared minus 4ac is negative. And that would make sense. Okay, remember that what we're looking at is the part under the radical. So if I get a negative radicand, if I do the square root of a negative, we know that we're going to get I values in there. And so that's why we end up with two imaginary solutions. Now, the reason why we get two imaginary solutions is because there are no real zeros. There's imaginary ones, but there's no real zeros because it never crosses the x-axis. Okay, so that's a little bit about what the different kinds of solutions mean. So we can really quickly figure out, just by looking at equation, whether it should cross the graph twice, once, or never. So here are a few examples. We want to use the discriminant to figure out the number and the type of solutions. For this first example here, I have an a value of 1, a b of -8, and a c of 17. Remember that to figure out a, b, and c, our equation must be in standard form, which means it must be equal to 0. If it's not equal to 0, none of this is going to work out to be true. I don't need to do the entire quadratic formula. All I'm going to do is b squared minus 4ac. B squared is going to be 64. -8 squared is positive 64. Then I'm going to do minus 4 times 1 times 17. Well, 4 times 17 is 68. So I have 64 minus 68. I get -4. Now this tells me this is the value of my discriminant. It is negative, so that means that I am going to have two imaginary solutions. One thing to point out, imaginary solutions always come in pairs. You'll never get one imaginary solution, okay? You're always going to have to get two. Again, the reason why we end up getting imaginary is because that b squared minus 4ac is what goes under here. I'd end up getting plus or minus 2I as part of my solution. And because I have an imaginary unit in there, the I, then that's why we get two imaginary solutions. We'd work out every single one exactly the same. This one, A is again 1, B is again -8, but this time my C is 16. So I get B squared, 64, minus 4 times 1 times 16, whoops, and 4 times 16 is 64. So 64 minus itself, I get this times 0. That means that I'm just going to get one real solution. It's real because it's a real number in our real number system. Why do I only end up with one solution when the discriminant is 0? Well, think about that. That would mean that the b squared minus 4ac, that's plus or minus, would come out to be 0. So the way we get two solutions is because I have to add first and then subtract. But whether I add or subtract 0, I'm going to get the same answer both times. So that's why we really only end up with 1. The last one, we would do exactly the same. Again, A is 1, B is -8. This time C is positive 15. 64 minus 4 times 1 times 15 gives me 64 minus 60. In this case, I'm going to get 4, which is positive, so I know that I have two real solutions. Okay? So that's all there is to the discriminant. That is the very last new thing that you have to learn for this unit. So we can just start working on our review now.